Hi everyone, this video is going to be on revisiting abstractions versus data structures. So first, consider the following loop that inputs n values from the keyboard and stores in a data structure named ds. The question is, what do we know about ds? So a couple of thoughts. Is it an array? Is it an array or vector? Is an array or vector a map, or could it be anything? And the answer is, it could really be a lot of different things, because as you know, most of the abstractions, especially the ones that are provided with the standard implementation or the standard library in C++, have overwritten the square bracket operator, which allows the square bracket operator to basically be a getter or a setter for any abstraction. So one of the really cool things about abstractions is just this, which is you can create behaviors that can be consistent among lots of different data structure, or lots of different abstractions. This is one of them, providing a consistent getter or setter type of method or operator in this case. In other languages, you might see that some like all the abstractions use get or put as their getters and setters. And that's just like that's one of the cooler things about the concept of an abstraction. And a container, or in different languages it's called different things, typically is something that holds multiple items of data, right? And so being able to loop through that is something that is going to be consistent across all abstractions. And so having that consistency within a language is really powerful. So I wanted to just start off this week by coming back to our abstractions versus data structures topic. I really hope that when you leave this class, this is something that's really cemented into you as something that you understand deeper than probably anything else in the class, is like being able to conceptualize what this class is all about. The class is called Data Structures because what you learn is how to implement abstractions, but they can't be done separately, right? So abstractions is something that you learn from the very beginning in CS, right? Even in your first CS class, you probably learned about lists or vectors or arrays. Depending on what language, that might have been an actual C array or an abstraction like a vector in C++. Or any of the abstractions in Python, or maybe you learned Java, whatever you learned. And as far as abstractions go, there's only so many major abstractions that are really common. And the cool thing is in this class you really learn about all of them. So the stack and the queue, priority queue, a set and a map, and then all of the hash sets and maps. So the unordered map in C++. And being able to really understand these abstractions and being able to use them to solve problems in an efficient way is a really powerful skill to have. And one of the ways that you can make sure that you understand these deeply and not just memorizing their behavior is by understanding how these abstractions are implemented. So, as we've talked about over and over again, is abstractions can be implemented with in lots of different ways with different data structures under the hood, and you can even implement abstractions with other abstractions. And so there are really only a few types of data structures, and then like major data structures, and then there are like 1,000 variations of them. So arrays and linked lists, you got to experience implementations with both of those, as well as trees, and also see how hash table works. This week you are going to be kind of putting all of this together and working on a problem where you have to kind of think about how to kind of efficiently use all of these different ways of storing data to solve a problem in an efficient way. And you'll also get to see, how some of these are implemented in different ways than maybe you have seen in the past. And then what we're going to be doing next week and the week after is we're going to be covering graphs. Graphs are not really like a whole new thing. They are just another kind of linked structure. We first look at linked lists, which are linear. Then we look at trees, which have top-down nature to them, and then we end with graphs, and graphs are just like even more general than trees, where all nodes can be connected in basically any way you'd like. So we're going to end with that, and there are so many cool algorithms on graphs, and they actually often use all the other abstractions as well. They also use the other data structures. So one of the things that's confusing is that a graph isn't really a data structure necessarily, but it could be considered one, and it could be implemented as one. But it's actually typically implemented with other data structures. So you're going to see that when we talk about it. But it's just a good, classes are very rushed, and you're always just like working against a deadline and turning in all the things. But it is good to step back as you're kind of going through material and continue to process these concepts that you're learning, and to look back at what we've learned and where we're going. So we've learned so much, and I think it's incredible to think about, right? How many things you learn in a semester in this class or in any class, right? When you look back, and probably when you first day of any class looked at any of the stuff you're doing now, you'd probably think it looked like a different language, like it looked like complete gibberish to you. And now you have this huge amount of skill and knowledge from all of the hard work that you've done. So that's kind of where we're going. And this week, as we are preparing for our next project, what we're going to be doing is going over some of these abstractions that we haven't spent very much time with. So we're going to go over the priority queue, and we're also going to talk about a couple of new data structures, because these are the main ones, and so you might be wondering what other things there are. We don't have time to program all of them, but after you program a couple of them, the other ones just kind of make sense, because you understand this deep, you're really deep in under the hood of the code. So it allows you to have this really good understanding of it. So we're going to look at heaps and tries, and some other things I don't really remember, but you'll see them in the videos. So that's what we're doing this week, and then we'll be moving on to graphs next week, 2 weeks on graphs. So that's it for this video. See ya.